Okay, good morning everyone, and welcome back to ISYS114 class week number 9. So before we start, just a quick reminder. So as you know, assignment number 2 due next week, week 10, Friday, 5 p.m. Okay, so this is the first component of this assignment. So this assignment has two components. The first component is So this assignment has two components. The first component will due next week, Friday, 19th of October, 5 p.m. The 15 queries you have, that will be submitted on iLearn, and there is already a link there. We already got some submissions. The second component of assignment 2, there is an in-class quiz that will be week 11. This will be in your scheduled class. Okay, so you are going to go in week 11 to your normal class, and there will be a quiz on iLearn online. There will be, majority of them will be multiple choices. Okay, so maybe one or two queries you need to type SQL statements, but the majority of them just query, just multiple choice. Okay, so each of them about 50% of the assignment. So as you know, assignment 2, the weighting of assignment 2 is 20%. 10% for the submission you will have, and another 10% is this online quiz. Okay. Okay, so today's the class. Maybe in the first hour or 1 hour and something, we will finish SQL, and this is the second module of this unit. As I told you before, this unit has 3 modules. Okay, the first one is database modeling, how we design a database. The second part, which we have been doing for 4 weeks now, which is database implementation, using SQL, how we can create tables and run queries to insert and extract data. And the last module will be the database advanced topics, which is a bit theoretical part. It talks about some important concepts you need to know about database, such as database administration, data quality, data warehouse, green IT, big data, and analytics. So some advanced topics you need to know. That will be the last 3 weeks. So today we are going to take slightly chapter 8. Okay. So if you check your handwritten notes, so the first 3 questions, they are about view and stored procedure, which we finish our last class with. So this is just to revisit these concepts again. So query number 1, write an SQL statement to create stored procedure named H1 name to display the name of hotel with ID H1. How we can do this query? So this is a simple one. So what I need to display here, only hotel name. So this is what I'm going to have in my select section. And my query is hotel ID is H1. So hotel name and hotel ID, both of them in hotel name. So I don't need to join any tables. Okay. So first, before you create the stored procedure or even the view, make sure first your query is correct. Okay? So I'm going to check my query first. I'm going to select. I'm going to display hotel name, so select hotel name. And from which table? From hotel table. And what is my condition? My condition is where hotel ID equals h1, okay, h1. And it is a good idea always to check your tables and see what is the expected output before you run the query, so you know if you got the right answer. So let me just run all the tables. So in my hotel table, H1 is called Merit Hotel. Okay, so when I run this query, so I got Merit Hotel. Okay, so my query is correct. Now I need to make a stored procedure, like a function or a routine, that when I run this function, it will show automatically the hotel name. So how to create a stored procedure? So in my database, hotel, I have tables, views, and stored procedure. Maybe I need to delete old ones. I created this in the previous lecture. And maybe also I delete the views. Okay, so I have no views, no stored procedure. So to create a stored procedure, so I go to the folder stored procedure, and I right click, and I click create stored procedure. So I will get this window. So first I need to give this function or stored procedure a name. So the question said name it h1 name. So h1 h1 name, yeah, h1 name. And between begin and end, I'm going to paste my code, which I checked, and I'm sure it is working as expected. So I paste my code here. Okay. And then I click apply. It will ask you, are you going to create a stored procedure? Yes, apply, and finish. Okay, so now the stored procedure is created. So how to run a stored procedure? To run a stored procedure, simply use the keyword call. Okay, and then what is the name of the stored procedure? It is h1 name, and then two brackets or two parentheses like this, and a semicolon. So this is how I call a stored procedure. So I will run this statement, and I get the output of the stored procedure. Another way to run the code is simply, when I go to the folder stored procedure, I have my created function here. So simply I will click here run, and as you can see, it creates the call, and here is the output. Okay, so this is question number 1. So in your assignment 2, you have question number 15, which is a stored procedure. What you need to put in as your answer, this function, okay, and the function call. So probably also you need to put the function call. So this should be your answer. Okay, so this is query number 1. In number 2, which is very similar to number 1, in query number 2, you need to create a statement or write a statement to create a stored procedure again, named hotel name, to display the name of the hotel with an ID, which is given as an input. And this is like task 15 in your assignment 2. So you need to create a stored procedure, but not a fixed one with no input. You should get something from the user. You should get an input from the user. So when the user give any ID, H1, H2, H3, the stored procedure will get this ID and display the hotel name. So I will not make much changes in my query. Okay, so I'm sure this function or this statement display only the name for H1 only. So before I create the stored procedure, I need to know the data type of the input. So what is the input to my stored procedure? It will be the hotel ID. So what is the data type of hotel ID? Character, yes? So you can easily go to the table, hotel, and you can see here the preview to this table. And you can see here hotel ID is character, and it has the length 3, so character 3. Okay? So simply, I'm going to create a new stored procedure. So here, create stored procedure. So what is the name of this stored procedure? It will be hotel name. Because this stored procedure is going to have an input from the user, so between these two parentheses or these two brackets, you put in, so this will be an input, and then give a name to this input, whatever name you want. So maybe my ID, maybe, and space, and then what is the data type? So the input will be an hotel ID. So the data type is char 3. Okay, so here how I specify an input to my function. So I start with the keyword in, and then I give a name to my input, and the name should not have spaces, should be one word. And then what is the data type of this input? And simply I'm going to just copy and paste my tested SQL statement, but instead of displaying H1 only, I'm going to display the hotel name where the ID is the input, and my input is called my ID. So here it will be check the hotel name which is entered as an input by the user. Okay, so I'm going to apply and finish. Okay, and here a stored procedure is created. How to run this stored procedure? So like the first one, but this time we have input. Unlike the first one with no input, we will have an input. So I call the stored procedure like call, and the name is hotel name. But this time between the parentheses or the brackets, I'm going to give an input. For example, H2. Okay, and H2 is a character, so I should have double quote. So when I run this statement, when I run this statement, well, there is one row returned, but it doesn't display it. I think this is a bug in Workbench. Didn't happen with anybody before. Sometimes it doesn't show the output. Or we can click run, and it will ask you in this window to enter an input. So, for example, H3. And okay, I will have to restart the MySQL Workbench. But this is how I call the stored procedure with an input. So call, and then the name, and what is the expected input. Okay, so give me a minute, I will restart the Workbench, but this is how it works. So query number 3, write a statement to create a view named Australians to display customer ID and customer name for customers whose nationality is Australian and who booked nights more than 2. Okay, so what I need to do, what I need to display here, I need to display customer ID and customer name. So I'm going to select, and I need to display customer ID, comma, customer name. Okay, from which table? So although I need to display only customer ID and customer name, which exists in customer table, but I have a condition who booked nights more than 2. So I need also to include a booking to check if this customer booked 2 or more nights. So I need to include customer, comma, booking. And as long as we have 2 tables, what is the first statement in where? So where, and the first table dot pk. So what I'm going to do here, I will make booking, I will give it a name B. And customer, I will give it name C. So where C dot customer ID equals B dot customer ID, and I have a condition that the nights should be more than 2, so and nights greater than 2. This should be the statement to display customer ID and customer name for the customers who made booking more than 2. To create a view, just simply I'm going to add create view, and then you give the name to the view, which is Australian. So the name is Australian, and the keyword as. Okay, so it is good to check first your statement, and then you create. You add the create view statement.
Sorry, just that last one. It also needs it for the nationality to be Australian.
Okay, yeah. So, yeah, correct. Here we should have the nationality Australian. So, and as well. Yeah, I forgot this statement. And I think it is called customer nationality. So, customer nationality equals Australian. Okay. And I restarted my workbench. So if it happens to you guys, sometimes when you run a statement, the output here tells you there is one record or few records displayed, but you cannot see an output. Usually this is like a bug in my workbench, so you need just to close it and open it again. So this is how when I want to run the last stored procedure, call hotel name, which is the name of the stored procedure H2, and when I run, and here is the output. Regarding the question number 3, this is already H2. Regarding question number 3, so first I'm going to check my query. So I'm going to select customer ID and customer name from customer and booking, where let me give it a letter C and booking B, where C dot customer ID equals B dot customer ID, and customer nationality equals Australian, and nights greater than 2. To run or to test this statement, yeah. So because the error here is the ambiguity error. So when you get this error, the ambiguity, it means what?
You've got to misspell your customer name.
So customer name here, customer, yeah, this is another typo, but the error here is the ambiguity error, or the field is ambiguous. What does it mean? It means there is a field exists in two different tables, and SQL is confused. It does not know from which table to extract this field. So we have customer ID here exists as a primary key in customer and as a foreign key in booking. So we need to specify from which table to get customer ID. So we need to put, for example, B dot. It means get it from the table booking. Or C dot, it doesn't matter. So I have here one customer, Adams Davis, who made a booking. It is always nice to go back and check. So if I see my table customer, how many Australians I have 2, C1 and C5. So in the booking table, who made more than 2 nights? So C1, he made 2, 3, so C1 is included. C5 actually did not make any booking. Okay, so I have only C1, the Australian customer, who made more than 2, which is 3 nights. So yeah, it is only this customer. To make a view, so before this statement, I will write create view, a view, and the name of the view is Australians as. Okay, so here's my folder, view folder is empty. So when I run this statement, well, the view is created, but of course I cannot see the output unless I refresh. And here is the view. This view is considered as a new table. Like you can deal with this view, which is called Australians, as if it is a new table. It is sometimes called materialized view. Materialized means it is physical view. It is created as a table permanently in the database. While there is other type of views called virtual view. So this virtual view is not saved permanently on the hard disk. It is just during the runtime. You can see a subsection of a table, but this is just during the runtime. It is not saved permanently. Here I have this view saved permanently on the server, so it is considered as if it is one table. So I can run this view like any other table. I can write select star from, and what is the name of this new table? Australians. And I see the output of this new table. And of course you can do whatever, like you can join this table with other tables if you want. Okay, so this was a quick review to views and stored procedure. The second section of this lecture, just talking about table view join. During the last couple of weeks, we used one method of joining tables, which is called ISYS114, which is joining the table primary key, foreign key in where. So we'll see there are different types of joins. Some of them could be useful in some special cases. So if we have two tables here, we have employee table with employee ID, name, and the department ID they work at. And we have another table called department, and the fields are department ID and department name. So in this table, the employee ID is the primary key, and in the department table, department ID is the primary key. Department ID here is a foreign key, so this is the FK, and these two tables is linked by primary key and foreign key relation, like this. So if the query is write a statement to display employee name and the name of his or her department, okay? So if we can do this using usual ISYS join, which we know, Okay, we are going to write something like select from. So I'm going to display employee name. So select emp name and his department name and comma department name, depth name. And these two fields exist in two different tables. So I need to join them. So from emp comma depth. Okay? And I need to join them. So where? So emp dot, the foreign key is department ID, emp dot depth ID equals the second table depth dot department ID. This is the usual way we used to do it. And this is called equi-join because we use equal sign to make this is the primary key of this table equals to the foreign key in the other table. Okay, this is a normal way. There is another way to join tables called natural join. In natural join, you don't need to specify what is a primary key in the first table and what is the foreign key in the second table. Natural join will try to find what is the common field between the two tables and join them naturally. Okay? If your database is well structured, well relational database, that means each table has the primary key field and it has foreign key to connect with another table, natural join should work with no problem. Okay? So I will do the same query but using different types of join. So I'm going to select from. So I'm going to select again emp name and depth name. Okay? And when we join, we say from emp natural join and the other table which is depth. Okay, that's it. So I don't have to specify, So I don't have to specify what is a primary key, what is a primary key in department table and what is the foreign key in emp table. Natural join will find what is the common field or column between these two tables and it will join based on this common field. Okay? If there are another like a common field which is not primary key, it will also do the matching. So this is a different way to join. Another way, and this one is important. Actually, I expose this part to just to tell you how to use join on, which could be very useful in task 13 in your assignment 2. It will work very well in task 13. So join to, I will have select from. So the same, I'm going to select the emp name and department name, and from emp join depth on, and then I again make something like equi-join, so emp dot department ID equals depth dot department ID. So here in join, I join the table emp and department, but here I have to specify what is the primary key in department and what is the foreign key in emp. Oops. Okay. So this is join on. So the three joining types, equi-join or natural join or join on, they will give the same output, but they just do matching between foreign key and primary key in different ways. So what is the output in any way in these three cases? So the output of equi-join or natural join or join on, it will be, so I have Abrahams, he work in department 2, Abrahams work in department 2, and what is the name of department 2? Department 2, marketing. So the output here will be Abrahams, and his department is marketing. And then Angela work in department 2 again, which is marketing. So Angela in marketing. And Joseph work in department 1, and department 1 is one sales. So Joseph and work in sales. And Sarah work in which department? In null. Okay, that means there is no foreign key here, and so there will be no matching. So it will just, so in the first three types of joining, the output will be like this. Just three records, Abrahams, Angela, and Joseph. While Sarah, because she does not have a foreign key, there is no match, and so its record will not be displayed. What about left and right join? So left join simply, in left join, it go to the first table, which will be considered as the left one, and try to find the matching for each one of the left table. Okay? So let me write the syntax first. So it will be select and from. So I'm going to select emp name and dept name. From, I'm going to, the first table will be the left table. So you have to, the order of joining here is important. Okay? So the other three ways, the order of joining doesn't matter. So I put emp or before department or department and emp, the order doesn't matter. But in left and right join, the order is important. So I'm going to link or join between imp, left, join, dept, on, and then I put emp dot department ID equals dept dot department ID. Okay, so how left join works? As I said, left join, it will take the first table here as a left table and the second table as the right table. It will get all the record from the left table. So the output will be like this. So the left table, how many records in the left table? We have 4. So the first one, Abraham's. And what is his department? So Abraham's work in marketing. So Abraham's marketing, Mar. Number 2, Angela. So Angela, number 2. And what is the department? Marketing. And number 3, Joseph, who works in number 1, sales. And number 4, Sarah. What is the department Sarah works in? Null. So, but it will write here Sarah and null. Okay, so how many records we will have as an output using left join? It will be the same number of records in the table on the left. Okay, so even if we have a record that has no match on the other joining table, it will have, like Sarah, it has null department. It will not show, it will show the null value. The other way will be right join. So if I wanted to right join, again the order is important. So this is left join. Regarding right join, I will have select from. So I'm going to select emp name and depth name from emp and right join. So right join, and it will right join the table department on, and then I put the primary key foreign key. So on department ID equals emp dot department ID. So what happened here? So this is my left and this is my right table. Because this is right join, so what happened is I will get the table on the right, which is depth, this one. I will start to find the match from right to left. So I start with D1, sales. Who works at D1? So D1, Joseph. So the output will be like this. Okay, so I will have, so maybe sales. Okay, and who works at sales? Joseph. Okay, so number 2, marketing, D2. Who works at D2? We have 2 employees, Abrahams and Angela. So I will have marketing, Abrahams, and then marketing again, Angela. Then we have accounting. Who works at accounting? Nobody, but I still have to include it because I have to check all the record on the right table. So I will have accounting, and I have here null. Next, I have customer service, which is D4. Anybody works at D4? No? So I will have customer service, and I will have null. So the number of records here should check all the records on the table on the right. So this is right join. Cross join simply multiplies the number of records on the right and the number of records on the left. So we have here like 1, 2, 3, 4 records on the table emp, and we have 1, 2, 3, 4 records on the table depth. So I will have one record like Abraham's sales, Abraham's marketing, Abraham's accounting, Abraham's customer service. Then Angela sales, Angela marketing, Angela accounting, and so on. So I will match each record with all the records in the table on the right. So the syntax is select from. I will select emp name and depth name from emp cross join depth on, and then I will have dept dot department ID equals emp dot department ID. Okay, and the out will be just matching each record on the left table and all the records on the right table. Okay, so some exercises, or one of the exercises here. So write a statement to display customer name and their check-in date using different joining methods. Okay, so let's try a few of these joining methods. So here's the query number 5 or question number 5. I need to display the customer name and their check-in. So I need to select customer name and check-in, I think. Check-in, yes. So this from customer and booking. So I have customer booking, yes. I can copy and paste this. Okay, so this is equi-join. So equi-join, I have the two tables in from and where I join the two tables. So when I run, how many customers or how many bookings I have here 7. Okay, I have 7 bookings. So when I run this statement, I should have seven customer names and their check-in. As you can see, some customers made different check-in with different bookings. Okay, using natural join, it will be select. So using natural join, so select customer name check-in from customer natural join booking. I don't have to specify primary and foreign key. When I run, I should get the same output. Using join on, so select customer name and check-in from customer C join booking B on C dot customer ID equals B dot customer ID. So here I join on and I get the same results and so on. So you can also do the same for left join. I just can copy and paste. So using left join. Okay, so in left join, what I'm going to do is I will get the customers, how many customers I have. I have 6 customers, and each customer I try to find his matching check-in. Okay, so why I have 9, not 7. So in the previous ones, I have 7 customers. When I run, for example, here join on, I have, can you see here, 7 rows returned, because in booking, I have 7 booking. But here, when I left join, can you see, for example, Emily Smith? Why I have Emily Smith null? Because Emily Smith, who is customer 5 here does not have any booking. As you can see here, I don't have any booking for customer. This is booking. Yeah, I don't have any booking for customer 5. Okay, so this is simply join. Why I include all this? Of course, for your knowledge. Second, because join on, it will be very useful to join the tables in task 13. So I will tell you some hints I mentioned in the night lecture, so to be fair with you. So the idea in task 13 that you have like table called team, and this table has a primary key team ID, and you have another table matches, and it has match ID as a primary key. It has also first match and second match. Okay, and you need to check if Croatia in the first or in the second as a second team. Okay, so what you need to do is you need to join these two tables. Okay, but not once. You need to join these twice, because you need to check this team ID. If this team ID is a first team, or if this team ID is a second team. Okay, and to specify, because you will have two connections, you will need to give each join a name. Okay, and then you need to check if Croatia is first because of with this connection, or second with this connection. What is the best joining method to use here? It will be join on. It will work, make it much easier to use join on to join these two tables. This is a hint. Hopefully that will make things a bit clear. Okay, so some concepts quickly I will also discuss with you regarding SQL. As you can see, this will not be in the assignment, as you can see, and this will not be in the final exam. Probably in the quiz, I can get one of the question from these topics. So that first topic is the difference between in and exists. Okay? So in and exists both check a correlation between outer query and subquery. So for example, if I make a query like this, select hotel name from select hotel name from hotel where hotel ID in H1 H3. So what does it mean? So I'm going to check if I'm going to display hotel name if the ID exists in this list. So after in, we have list of values, and I'm going to check. I'm going to display hotel name if the ID exists in this list. If the query is display hotel name where this hotel had any booking, okay? So if there is any booking for this hotel, I need to display this hotel name. How to write this query? So the question is display hotel name with any booking. If there is any booking in the hotel, display this name. How to write this query? So I'm going to display the hotel name. So select hotel name, and hotel name from which hotel? From which table? Hotel. where hotel ID in, then I will have a subquery. This is using subquery. Select from where, or just from. So I'm going to select hotel ID from booking. Okay. So what does it mean? So here I have a subquery. So this query is called subquery. Okay? And this, when I use in, this type of subquery is called non-correlated. What does non-correlated mean? It means there is no interaction or correlation or association between executing the inner query or the subquery and the outer query. So how this query will be executed? The subquery will be executed first. Okay? So I'm going to select hotel ID from booking. This query will return a list of tables. Like if I check the table booking here, what are the hotels with query? H1, H2, and H3. So this query, this subquery, will get the hotel ID with any booking in the booking table. It will have H1, H2, and H3. Okay, so this subquery actually will be replaced with this list of values. And then the outer query, select hotel name from hotel, where hotel ID is one of these IDs. Okay, so here the inner query will be executed first, independently from the outer query, with no relation with the outer query. And after this query is finished and return a list of values, the outer query will be executed. When we use in, make sure that this field, hotel ID, is the same as the one returned from the inner query or the subquery. So this hotel ID should be the same as this one. So this is very important, that the inner query or the subquery will return a field exactly matching the field in the where. Okay? What is the other keyword we have, which is called exists? So I will do the same example but using exists. So it will be, the first part will be similar or maybe the same. So using exists. So I'm going to select from where. So I'm going to select hotel name from hotel, where I just use the keyword exists. And then I start my inner query. So in my inner query, select from, and I need to join the tables. Where? So I'm going to select here, and when I use exists, it doesn't matter what I'm going to select. So I'm going to select maybe star from booking. And here I need to join the two tables. So where hotel dot hotel ID equals booking dot hotel ID. Okay, so what you observe in the difference between using exists, I try to put them side by side if I can. Can I? No. If I zoom out. Okay, so what is the difference between using exists and using in? So here using in. So the main difference is, number one, in the using in, the subquery will be executed completely first, okay, with no relation with the outer query, and then the outer query will be executed later. Using exists, actually I join the two tables, so for each record of the outer query, it will check the inner query. So that's why this method of subquery using exists is called correlated subquery. Another difference, what is the return of the subquery using in? Yes? What is the return of the subquery using in? It is a list of values. So the return of the subquery is list of values. What is the return of the subquery using exists? It is only true or false. Okay? It just check if the hotel exists in the booking. Okay? And if it exists, it will return a true. Exists, so displays its name, or false, don't display its name. Okay? So the subquery return only true or false. So if I try this example, so write a statement to display customer name who made any booking. Of course, using correlated, which is exists, and non-correlated using in. So this is number 6. So I'm going to select. So I need to display customer name. So I'm going to select customer name. From which table? This should be from customer table. Where? So which field I'm going to match between the outer query and subquery? It is customer name. So where? Customer ID in, and my subquery will be select. I should, as long as I use in, the field before in should be the same as the field returned from in. From booking. Okay, so here is in. This field is the same as the one returned from customer ID from the inner query. To display only the subquery, I will just select the subquery and I'm going to run selection. That means I'm going to run only the subquery. So I'm going to run. So it shows me here all the customer IDs in booking table. So if I see booking table, here is my booking table, and here is customer ID. So it returns these 7 customer IDs, C1, 2, 3, 1, 4, 2, 1. And this is the return I got here, 1, 2, 3, 4. So this is the return just from the inner query. To run all the query, the nested query, it will show me, just this one, customer ID. I don't know why when I type customer, I always type E before M. It happens with me all the time. Okay, it will show me the customer names who made bookings, and they are customer 1, 2, 3, and 4 only. So I have, even if I have repetition, duplication, it will show only customer 1, 2, 3, and 4. Okay, so this is using in. So the return of this subquery, it will be a list of customer IDs, which is C1, 2, 3, and 4. Like you can imagine, this subquery will be replaced with C1, C2, C3, C4, like this. So imagine that this subquery will be replaced with the IDs of the customers who made booking in booking table. Okay. What about exists? So this is question number 6, using in, then using exists. So first, I don't need to have a field before exists. Second, instead of in, I will have exists. And after select, I don't need to select or show anything, because it will just return true or false. If the customer ID exists in the nested query or the inner query, it will just return true or false. So here it doesn't matter what you are going to return. You can put star if you want. From booking, and you need to join here the inner query and the outer query. So from booking, where, and you can put customer.customer_id equal booking.customer_id, customer.customer_id equals booking.customer_id format. Okay, so here using exists, it will get the customer ID from customer table and then go to the subquery and check if this customer exists in the booking. If this customer ID exists, the inner query will return it true, and then it will display the customer name, and so on. So it will go to customer, get the first C1, and go to booking, and try to find if C1 exists. If true, if C1 exists, it will go back to customer and return customer name. Okay? A very strong point in exists. As you can see, exists and in, both of them, the return is nearly the same output. The return is the same output. But the execution is different. Either completely execute the subquery and then return the output as a list to the outer query, or keep going between the outer and in and try to find match. A strong point in exists, it returns true if the first time it finds the existence records. What does it mean? For example, customer 1, first customer 1, C1. When I check if C1 exists in booking, it will get C1 and go to booking. And the first time I find C1, I don't have to continue checking C1. The first time I find his existence, the function will, or the subquery will return it true. Okay, so this is very powerful. Like I think you will read in the note here. Exists is much faster than in when the subquery is very large. So both of them behave the same, like they get the same result, but just the performance. So if the booking table is very large, I have thousands of records, and so the customer exists many times, I don't have to check thousands of times. The first time I find his existence, I will just return it true. Okay? Make sense? Okay. The last topic in query is union and union all. So union and union all is used to join the result of two queries. Okay? Example, if I wanted to check or to display customer IDs who made bookings in H1 or H2, and the question is union or union all. To display the customer who made any booking in the customer ID who made booking in H1 or 2, so I'm going to select customer ID from booking where hotel ID equals H1. Okay, so this is the first query, and I'm going to just copy and paste the second query. This is H1 or H2. H2. So if I check the booking table, so H1, how many customers made booking in H1? So here is the booking H1. We have customer 1, 2, 3. Okay? So customer 1, 2, and 3 made booking at H1. And how many customers, or who are the customer IDs that made booking at hotel H2? So we have 1, 4, and 2. Okay? If I wanted to combine the result of these two queries. So first, I don't need semicolon here. I can add brackets just to organize my code, but it's not necessary. To use union, so do you remember what are the IDs who made booking at H1? 1, 2, 3. Okay, so here I can write here. The output of the first one will be C1, C2, and C3. And what was the output for those who made booking at H2? 1, 2, and 4. You have good memory. C1, C2, and C4. If I write union, simply I will combine the output of these two queries, but I will remove duplication. So as you can see, C1 is shared or common between these two outputs, and the same for C2 is common between these two outputs. So I will have C1, 2, 3, and 4. So I will remove duplication. So I will have 1, 2, 3, and 4. If I use union all, simply I will combine the output and I will keep the duplication. So I will have the output as C1, 2, 3, and then 1, 2, 4. So when I run union all, I'll have 1, 2, 3. This is from H1, and 1, 2, and 4 from H2. So union all and union, both of them join the output of two queries. The difference is, I can write this here as a note. So both union and union all join the output of two queries. The difference is union join the output and remove duplication, while union all join the output and keep the duplicated records. Okay, so this is simply the difference between them. Okay, so far we finished SQL part. As I said, exists union all, and these different type of joining. Nearly you don't use them in assignment 2 and not in the exam. Of course, in is already, we covered this before, so in is included in the exam, the final exam. But I think to use one of these concepts in the quiz, in the week 11 quiz, Do you have any preference? I give you the options. Like I gave the option to the students in Wednesday class lecture, and they said union and union all. Do you agree with them, or you have different preferences? Okay. Okay. So maybe I will include union and union all as a question in one of the multiple choice in week 11 query. Okay. So far, anybody have any question in SQL or any general question in assignment 2? If you have a specific question, you can ask me after the lecture, or maybe next week I can dedicate more consultation hours. Okay, and please make use of consultation hours. We have almost 10 tutors, and everyone has 1 hour, so there are 10 hours of consultation. So any question, guys, before we start this chapter 8? All good? I will consider this silence as all good. Okay. Okay, so this is the end of SQL and the practical part of this course. So this course we had, besides the first week, which was the introduction, so we had 4 weeks of database modeling using ER, EER, CDM, LDM. And then we had 4 weeks of SQL. So part of this lecture and the next 3 lectures will be a bit theoretical. We will cover some book chapters. We'll try to give you the summary of the summary. Okay, so each chapter is 20, 30 something page. The slides, 50 to 70 slides. We'll try to give you the summary of the summary, and we will tell you what are the important parts you should concentrate on. Okay? And I think in this part, the theoretical part, in the final exam, you will have, I think, 3 questions or 4 questions. Very limited part. Okay. In chapter 8, it is called Database Application Development. It talks about how we develop a system that has a database in. So the first question is, what is client-server architecture? Have you heard about this term before, client and server? I think yes. So can anybody tell me what is a client and what is a server? Yes?
Client is a program that accesses information from server, and server just stores the information.
Okay, very close. Like you said, client is, I will just add, instead of a software, you said it could be a machine. Okay, like your laptop, when you access your email, your laptop is the machine. Or maybe you mean the software on the machine. Like when I access my email, I access using browser, for example. Okay, so it could be the software on a machine or a computing device that access another device to get information or to request information. Yes, very good. So client server architecture, this is designing an information system to be like this. You have a server, and from the name, server means it offers a service. And you have some clients, such as you access using your laptop, maybe your mobile phone. This is mobile phone, yeah. Okay, or maybe from another desktop. Okay, so the server has some services, some information. Can anybody give me an example of a service offered by a server? You said you request data or service. An example of this data could be maybe a web service, like websites, or maybe email service, or maybe file service, and many others. Okay, so the server can host websites, or can host email, can host files or videos, whatever. And clients, or any client, will send a request to the server to access this website, or access this email account, or download this file. and the server will reply with the service. Here is the website, or here is the email inbox, or here is the file you want to download. So we can say that client-server architecture, oops, can't see. So I assume you did not see this. Okay, so as you said, the server consists of, this is a machine, a computing machine that has data, which could be web-based, like websites, or email-based, or file-based, and clients accessing the server request a service, request a website or email, and the server will reply with the required data. Okay? Sorry, it was not on the screen. So we can write down what is a client-server architecture. It is a design where services or data, as you said, is data or service is or are hosted on, it is like a computer, we can say, that provides this service to clients when requested. So, to design a client-server system where the server will have some data or services, and it will provide this data to clients when the client requests this service. This application, the web application, will have some components. So what are the components of client-server architecture? Or what are the layers? It is like layers. So we have three main layers in client-server architecture. We have presentation, logic, we have processing, logic, and we have storage, logic. Let's take an example. When you access your Facebook page, for example, you as a user, what you can see? You can see your Facebook main page. You can see some menus, some buttons, some links. Okay? So you as a user, this is what you can see. You can see the post of other people you follow or your friends. So this is what you can see as a user. So what you can see as a user, this is presentation logic. So presentation logic is formatting, and presenting data to the user, the end user. Okay? Also, in this logic, besides formatting and presenting data to the end user, also it managing user input. And of course, from any input device. Like when you click on, for example, friends, okay? You as a user click on a link. This click should be managed, or it is considered as a command. I need to see the list of my friends. Or when you click on photos, this click from you as a user is considered a command to see the photos. So the logic or the component of the system that manage your inputs, this is presentation logic. What about storage logic? So from the name storage, so it handles all the data, storing the data. Okay? So DBMS, this manage stored data. And what is the software that manages this data? So of course we have our database plus DBMS. And what is DBMS? Database Management System. And why do we need DBMS? Why do we need to have DBMS? Because imagine your database as if it is like a baby. So here is my database. No control on this database. Anybody want to give this database anything, it will accept it. Anybody want to get data from this database, it will give it to you. Okay, so there is no control. Database does not have any control. It is just a place where I can save tables and records. But I need some kind of control, some guard to protect this database and decide who can access what. So I have this kind of software, which is the DBMS. So you as a user, you cannot access DB directly. You as a user should access DBMS, and DBMS will decide what you as a user can see. Okay? So imagine if there is no DBMS, all the gradebook on iLearn, which is saved on a database, will be available for anybody to access and do whatever you want. So can you imagine you as a student can see the gradebook of all the group, and you can view, you can edit, you can delete, no control. But DBMS, when you log into iLearn, you access as a student. You have some permissions. You can see only your record. You cannot see anybody's record. You have some permission. You can only view. You cannot edit. Okay? So who decides what you can do in which part of the data? This is DBMS. Okay? So stored logic, this is managing the stored data, and that consists of the database, the place where we save the data, and the DBMS, the software that manages the database. The central part, which is called processing logic. So processing logic is like the brain, the mind. So not only presenting, displaying the menus and buttons and links to the user, or not storing data, but matching between what the user wants to see, the click of the user, and what the data should be extracted. So this is called processing logic. So it is like the brain of the system. And it consists of some tasks, such as data processing logic. So data processing logic includes, like, for example, verification. So when you, for example, log into iLearn, you type your one ID and one password. There is part of the system to check if this ID exists in the system and if this password match the password stored in database to verify you are the right user. So verifying some data is data processing logic. We have also some business rule. So some business rule. So business rule usually exists in DBMS. So as I told you, when you log into iLearn, you as a user have some permissions. You can see specific part of the data, okay? But sometimes we need to add extra permissions. So we program this as a business rule, okay? So this is in the processing logic. Like, for example, the marks of assignment 1, it is on iLearn, but I make it invisible. It is still invisible. So I make a rule. This will be invisible for students. tutors can see it. So this is a business rule that I specify a permission student or someone can see or cannot see part of the data. So business rule, additional rule besides DBMS rules. So usually DBMS has this kind of business rules or permission, and we can add some more in the processing logic. And also we can have data management logic, okay, to identify necessary data. Like, well, for example, when you fill in a form, some fields are optional, like optional, you can leave it blank. Some fields are mandatory, you have to enter. So we need to have some kind of processing logic to decide these fields should be entered and what kind of data should be included. So all this kind of checking and permission and decisions are in processing logic. Okay. So a question which is important: what is a fat client and what is a thin client? Okay? So what is a fat client and what is a thin client? Let me ask you, presentation logic, where presentation logic should exist? On the client or on the server? On the client, yes, because this is what the user can see. So when you, as I said, when you access your Facebook page, on your computer, you have the page with menus and buttons and this colored page. It is on the client side. So if we, so here is the presentation logic, and we have processing, the mind processing logic, and we have storage. As we said, for sure, presentation logic, what the user can see, exists on client side. What about storage? Is it on client or server side? Sorry? Server side. So when you access your gradebook on the server, it will never copy it to your computer. So storage logic on the server side. What about processing logic? The decision maker, the mind of the system. Is it on the client side or the server side? What do you think? Server? Anybody said client? Well, it can be on the server or it can be on the client. So if processing logic on the server side, as you said, so the server will have the storage, the database, and it will have the routine, the code that does the processing and decision making. The client will have only the presentation, just to display the output. So in this case, this client is called what? It's called thin client. So thin client is a client where only presentation logic is done on the client side, while the server side will do the storage and also the processing. And I assume you can figure out now what is fat client. So fat client is a client so we have server and we have client. So in fat client, so this is called fat client. We don't insult the client, this is just fat client. Okay, so in fat client, only on the server we will have the database and DBMS, while on the client, when you access a website, for example, some website adds some functions or send some function to your client to do the processing. That's why the client will have to do a lot of processing. So client will do the processing logic and the presentation logic. Which one is better? If I can ask which one is better?
I was thinking you should be having it on the server would be better, right? But I'd imagine there would be some benefits.
Yeah, you mean thin client?
Yeah.
To have all the processing on the server. So this is better for...
I don't think it's a standard that would be better, but I'd imagine the client would have some sort of privileges or there'd be some reasons why it would be better.
Yeah, so if, of course, from business owner point of view, I will have a server that just do the data storage, and I will send all the processing to the client to do on his machine. That means my server will not be under stress. Okay? But of course, client, his machine will be under stress to do a lot of processing and verification and stuff. But of course, not all the clients, especially now, clients are like mobile phones or which does not have much processing power. So from client point of view, it is better to have thin client, so my client does not have to do a lot of processing. So, but life is not black and white like this. We now have distributed system or distributed client. So where the server will do storage plus some processing. So in the distributed, for sure client will do the processing plus some, for sure client will do some presentation plus some processing. So they share the load of processing. Some processing will be done on the client and some processing will be done on the server. So they share the processing load between client and server.
Is that also because, I'd imagine as phones or laptops, computers, that sort of thing become more powerful, the client can take on more load?
Yeah, so like if the server is smart enough to identify each client and see if, for example, you access a system using a laptop with enough power, so it can send you some processing, more processes, while if you access using your smartphone, it doesn't have that much power, so it can send little. So that will be, of course, more smart way of distributing processing. So the next question, what is application partitioning? What is application partitioning? So from the name, application, like Facebook is an application. iLearn is an application. eStudent is an application. Sydney Train 131500 is an application. Okay? So do you think this application exists on one server? Like, do you think Facebook exists on one server? So I assume with 3 billion users who can access maybe 100 million access at the same time. So it is hard to have one application on one server. So it is better to distribute this application. For example, when you access iLearn, do you think iLearn exists on one server? As I know, only the Gradebook exists on a server, not in Sydney, actually, it is in Adelaide. Okay? So where you can download the slides, it exists on other server. I think in Macquarie, in E6A. So just as one page, you can see each part is located in a different server. It is partitioned. So what is application partitioning? It is dividing one application across different servers. Okay? So if I ask you what is the advantage and what is the disadvantage? So what is a good point in application partitioning, or dividing one application across different servers? Can anybody come up with something? So maybe advantage, I can summarize your point to distribute, and this is the main one, distribute workload. Especially if my application, we expect many concurrent users, many users access at the same time, distributed workload, okay? And especially if this application is expected to be accessed globally, like Facebook, nearly anybody does not have a Facebook account? Am I the only one? You have, okay, number 2, yeah, thank you so much. I feel I'm the only one in the whole world, but yeah, I find some people share me. They don't have Facebook account. So distribute workload, okay, especially if it is accessible or should be accessed globally. What is the main disadvantage? Okay, number 1, management. The management of different access.
Also management of access and maintenance, I imagine.
Okay, more maintenance. Okay. So you have not one server that has the application, you have 10 servers, and it has the same application. So if you wanted to make updates, I assume if Facebook add a new feature, it has to maintain and make sure there is a kind of synchronization between the servers. So more maintenance. What about security? Which one is more secured? The first one? So to have, well, there are two different point of views. If you have all your application on one server, maybe it is easier to protect. But if this server fail, your system, the whole system failed. While if you distribute the system across different servers, bit difficult to protect or against any attacks, but your system will be can be run up and running if something fail. So maybe here we can say security is easier, and the system will be more accessible because I have the system distributed across many servers. Okay. This is application partitioning. Number 5, what is a stored procedure and what are the advantages? And this is also an important question. So stored procedure, which we have just done few examples. So what is the idea of stored procedure? Like if I have a database, let's say this is Macquarie database, and I have like different clients, maybe different tutors, They send some query to see the name of the student, for example, who get less than 50%. They send a query, maybe select student, this is just example, so student name from the table student, where grade maybe less than 50. Okay, and imagine we as a tutor do this all the time. We send the query to see how many students in each class get less than 50. So we send this query hundreds or maybe thousands of times every semester. Okay, so this is a bit more traffic to send from the client, tutor client, from the client to the server. So what we have done in stored procedure, so simply we create a function. We create a function or a routine. This function will have the code. So this code, select from, will be saved on the server side. And how we run the stored procedure, you remember what is the keyword to run a stored procedure? Call. Good memory. So we just call So we give this a name, for example, S1. Just call S1. So this is simply the idea of stored procedure. Instead of sending a query or a code many times between client and server, we save this query and give it a name, and we simply just call this function. So we can say that stored procedure are, or procedures are modules of code that implements an application logic, okay, and it is saved on which side? On server side. So what are the advantages and disadvantages? Advantage. Let's say start with advantage. What are the advantages of stored procedure? List 3 or 4. Anybody can come up with some advantage of having stored procedure? Instead of sending the query over and over again, we save it on the server.
Be a lot easier to call it, essentially.
So easier to run. Yeah. So I don't have to write the whole query. I will just call it. So maybe easier to call or run. Okay. So regarding that, for example, network traffic, is it need more traffic or less traffic? Less. So I don't have to send this query 1,000 times. I will just call it. That's it. So save network traffic. Okay. Regarding security, is it more secured or less secured? Because, by the way, when you send any request to the server, you don't send only the query, you send also your details, your username and password. Like when you use, for example, Ash server, Macquarie database server, when you just write any simple query and you run, it will get your one ID and one password with each query to just make sure this query belongs to this user. So your actually user name and password is sent with the query. But when you call, you don't have to send your critical information with it. Okay? So in number 3, it is like security, improvement in security. So there is improvement in security. And we can say also there is improvement in performance. For example, make a typo in this SQL, I have to fix the error and send it again. But if the function is already stored on the server, I just need to code. So I don't have to make a lot of mistakes. What do you think? Using stored procedure, is it going to? Are we going to have thin clients or fat clients? Like when we save the function on the server, do you think the load on the client will be less or more? Will be less, because you as a client, you will not have to send a lot of code and receive the data. You will just call the function. So we tend to create or make a thin client environment, which is preferable. What is the main disadvantage?
I would imagine the ease of changing the request slightly. So if you say anywhere below grade 55 would be slightly
Okay, so disadvantage. Number one, harder to modify. I will take your words. Modify. So I need someone to change the query on the server. So not anybody can access the server, only the server admin. So if I wanted to change, as you said, for example, we make the failed mark not 50, 40, for example. So we have to contact server admin to change the query on the server. Maybe another one. If we decide to change, because this stored procedure is saved not on the server, it is saved actually on the DBMS. So the stored procedure are saved on DBMS. And if we decide to upgrade this DBMS or change this DBMS, maybe we are not going to use MySQL, maybe Oracle, or Microsoft SQL Server. Different DBMS, all the stored procedure will be lost. So it depends on DBMS, and any change in DBMS, so any change in DBMS will need to change the actual stored procedure, Okay? So we don't have much control on this stored procedure. The next one, okay, good. What is the 2-tier and 3-tier client-server architecture? So in 2-tier, which is a bit old but still exists in a small system especially, so in 2-tier, we have just a client and we have server. And the client sends requests to the server, and the server sends a reply. This is called what? 2-tier client server. Because I have only client and the server. The server is going to do a lot of work. The server is going to do the stored logic and some processing logic. So on the server, we'll have stored or storage logic plus some processing logic, which could be a lot, especially if we have a big system like in Macquarie information system. We have almost 40,000 students. So if a few thousand access Macquarie website or Macquarie I learned to do something, this is a heavy load on the server. Okay? So that's why 2-tier is suitable more for small business. Okay? Maybe information system for small school, for example. What about 3-tier architecture or 3-tier client server? We will have client. We will have a server called application server, and we will have another server with database called DB server. Okay, and this is now more common for big business. So we have here 3-tier. So we have client, 1 tier, application server, another tier, and database server, a 3rd tier. This is called the 3-tier architecture. Yes, so it is DB and of course DBMS. Good. Well, always with DB, DBMS. DB cannot go by itself. Remember, it is a baby. It needs someone adult to look after. So when you, for example, access your email, maybe, or access iLearn, so you as a user send your one ID and your password to the application server. Application server will get your one ID and one password and decide what I need to do with this one ID and one password. I need to check first. So it will check with Macquarie database. Is this correct? One ID and one password? If your one ID and one password correct, the database server will return yes. And then, for example, if you log into iLearn, okay, give me, this is student iLearn page. It is his profile or his page. And then the database will return with your profile, your page, and then application server will return your iLearn page. Okay? So the three-tier architecture is very useful, especially in the case the web page is dynamic. So the three-tier is used especially when we have dynamic page. And what does dynamic page mean? What is a dynamic page? Like, do you think your Facebook page is static? The page is just, like if you see the Facebook page without your data, it is just white page and there is light blue banner. That's it. But what happens is the application server gets the list of your friends and put it on the left side. Get the list of your photos and put it on top. Get the new posts and put it in the middle. So it actually builds the page. When you click login, this page is built, is created for you. So the page is not static, it is dynamic. It means it changes. If you access your Facebook after 1 minute, you will see it has a different page, different content, different posts. Okay? So the page is built dynamically. So what are the benefits of three-tier? The main benefit we can see, it is, as I said, dynamic page or pages. Also, it can host many concurrent users. Many users can access, because now the workload is distributed between application server and database server, so the workload is now distributed. And sometimes, like application server, don't think of application server as just one computer or one server. It can be multiple. Okay, they can work in synchronization. Okay, so I will stop here. So this is like a good part in chapter 8. We will continue chapter 8 next time and also chapter 9. Thanks everybody for coming. Have a good day, good weekend. Please don't forget the due date for assignment 2